multiple crystal phases like cubic, tetragonal, orthorhombic, rhombohedral. So using this video you can do your Rietveld refinement for mixed phase. So by step here I am showing you one example for barium titanate. As we all very much aware that barium titanate is exhibit in the two major crystal structure, that is the tetragonal below room temperature to up to 120 degrees centigrade, and above 120 degrees centigrade it just transformed to cubic. So another important thing is that barium titanate also exhibit in the both phases at the room temperature depending on the experimental condition. So here I will show you how to do the Rietveld refinement for mixed phase of barium titanate. So if you see before starting your Rietveld refinement, please note your lattice parameter, structural parameter for tetragonal. Depend on your crystal structure. Here I am showing you for tetragonal cubic. So you just note down what is the crystal structure for the one phase and the crystal structure for the another phase, their lattice parameter and their atomic coordinates in their respective crystal structure system. After that you just note down when you adding the another phase, you just try to remember or try to note these parameters you have to initially give for the initiate the refinement process, where scale U, V, W, eta 0, IGX. Here I'm just telling you that we are just taking the peak shape as the pseudo white. Okay, so now I'm going to start. So first you just open your software foolproof, and then after open this foolproof, yes, then you go to the EDPCR. Here I am not showing you how to make the input file. Input file is just same. You just take your XRD in the DAT format. Means one column contain the 2 theta, another column contain the intensity, and nothing else. So you just I'm just showing you the first general. Then you just note down the phase name. Then tick optimize calculation according to the particular option used in this job. Then you go to the pattern. You just go to add, then data file, and just import your data file where you have placed your input files for the refinement. So just I have shown you here. I am just putting my data on the desktop. So I am just taking this data. Okay, open. Okay, now here you choose free format 2 theta step size and 2 theta final. Then we just go to the X-ray, then pattern. Here you choose pseudo white. Okay, after choosing peak shape as pseudo white, you just go to the theta minimum. So if you have not remembered, then just go to your input file and just open your input file and see what is the so this is the initial angle, this is a step size, this is the final angle. So in this format you just put your values, like here 10, then the maximum angle is 90 degree, and then 0.02 is the step size. Okay, then go to the background, you choose 6 coefficient. Then okay, after that you go to the phases. Here you just give your first phase. Here I am just telling you the tetragonal and structure Rietveld, calculate automatically. Then go to the contribution of pattern, tick on the current phase, and again you choose the peak shape as pseudo white. Okay, then okay, now go to the symmetry. So you first just give the space group for that particular crystal structure, as I will show you, as I have shown you in the start of this video. So you just go to this and then okay, and then you add another phase. and try to remember. Once you add, then there is no need to go back to check. Okay, you just try to remember this. Then you put cubic, and then contribution to pattern again you choose pseudo white, and then okay, then go to the symmetry, and here you put PM3M as the space group for the your cubic crystal structure of barium titanate. Now go to the refinement, and here you see there are two phases already shown here. So let's suppose we are taking the 15 cycles of refinement in each process of refinement. So now first you go to the place the value for the, as you know, there is a I have already shown you. Okay, so just we have open and just make this window small to place this value. So here I am just taking for the atom for the phase 1. So just I am taking there is a 4 atoms. So we just insert 1 2 3 4 atoms, and then here you first put Ba because we have written it, and at n type you just write down this number, then x, that is 0 0 0, and the thermal parameter you just initiate with the value 1. And occupancy, you can keep this occupancy based on the YCAF position at the site is 2A or 4A or 8A. Otherwise you just see here the one barium atom, so you just place 1. Then titanium, here you put Ti plus 4, then here your 0.5 0.5 to 0, then 1, then again 1. Now oxygen, that is O minus 2, so here oxygen 0.5 0.016, again the B parameter is 1, and here you just dissociate O3 in two parts because O1 and O2. So in barium titanate, the A and B axis and another one the C axis, you can keep 1.5 1.5, or you can also keep 1.8 1.2 depending on the your crystal structure. So here I am placing 1.8 for O1 and O minus 2 for this is the 0.50 0.51500, then again 1, and this is 1.2. So if you see here, overall the summation of these O1 and O2 is 3. So fix all, then okay, then go to the profile and put the lattice parameter for this 3.99 3.99 4.03, and the angle is 90 90 and 90, because for the tetragonal alpha beta and gamma is 90. Again fix all. Now you go to the phase 2. So in phase 2 again there is a, here there is a 3 atom only. So 1 2 3. So Ba, so Ba plus 2, and this is 0.5 0.5 0.5 1, and this is 1. Then titanium Ti plus 4, then 0 0, and now B is again 1 again 1. So now go to the oxygen. Oxygen is O minus 2, and the atomic coordinate for oxygen 0.5 0 0 1 3. Again fix all. Okay, now go to the profile parameter for the phase 2. So here you see all the parameters 0 0. That's why I have requested you to kindly keep these information initially starting the Rietveld refinement. So here scale is 0.1, E minus 2, lattice parameter is 4.0059, then alpha beta gamma 90, and UVW. So U value is 0.004133, V is minus 0.007618, W is 0.006255, and eta 0 is 0, Ig 0, and X is 0.001896. So I fix all. Okay. So as you completed all the process, now you just okay and try to save your file by this run full profile. So first you create your file. So bt.dat, this is the file name of your input file. So this is create. Now go to your input file here and save by this name. Okay, and now you just choose your input file and run. So when you run, so I'm just hiding this. Now one by one you define your process, like first you initiate with the first phase. Okay, alpha, beta, gamma. Okay, and then save. Then you run. Okay, so when you run, okay, so now the same input parameter for phase 2 you also choose, because it just initiate the process. If you will not run for phase 2 also this profile parameter, then your refinement is not started. So now you just save. Now you see the difference. Okay, so now you see here how your chi-square reduces, and then you go to first refine the background file. So in one by one you choose the background file and refine. Okay, so now you just choose refinement one by one. So here you see the differences. Now you just refine the instrumental parameter like 0 and background parameter for the next value, and slowly you see the differences how this data is fitted. So here you see the red one is your the experimental data and the black one is your the generated data, and this blue line is your difference between the red and the black one. Now you just keep it for the both the phases. Okay, so here when you run you can see the output, and here output is in the lower section. You just see the what is the fraction for your phase 1 and phase 2. So this is your phase 1 and this is your phase 2. So here you see this phase 1 is 88% and this is the 11.44%. So in this way you can determine what is the fraction of phase of tetragonal and cubic is present in your XRT. Okay, so one by one you just refine it, and just try to run. So when it is completed for phase 1, your background, then just you go to this after background you just refine using this placement parameter, just save it and run it. Okay, so when you run, then now you start for the profile parameter one by one. So first you then save. So okay, so in this way you now you just refine all these parameters for profile. So now here you start for the profile 2, and one by one in the same way You refine the parameter of profile parameter for phase 2 also, and when you run it, you just see the differences. Okay, so you just go to for profile 2, and then you just choose one by one. So as you now refine the profile parameter for phase 2, so now you can see the difference how this fitting will the superimpose on this, your black one is a superimpose on the red one. So you just close this, and now you just run for the phase 2. You just first untick and then go to the phase 1 or phase 2 profile, and go to the preferred orientation. Here you see the preferred orientation is for this both phases. So after doing this refinement, now again you refine your profile parameter one by one, but this time you just choose the continuously one by one all the parameter, not individually. Okay, so try to refine in this way. Okay, now you choose all the parameters one by one. Okay, so as this refinement goes on, you see the difference in the output file, that is your phase fraction is now changed. So here you see phase fraction 68% tetragonal, 31% cubic. Okay, so now again do the refinement, and so now you just choose this background parameter one by one collectively, and you see the refinement, how good this refinement would be. Okay, now choose all the parameters. Yes, try to also keep in mind that when you refine this profile parameter and background, first try to do your best to refine this profile parameter and background. Okay, thereafter if required, then go to the atomic profile. Otherwise it is good for you if you achieve the best fitting during this two parameter refinement. Okay, so now if you all the parameter refined, now go to the this parameter pattern 1, pattern 2. So here you try to refine these four parameter together. Okay, so now you can see how good this refinement is. You can see how good this refinement. So now the same parameter you refine for phase 2, that is the u, w, eta 0 and x. Then okay, then save it. Okay, so now go to the atomic file. So in atomic file you first refine the occupancy, so 1 and 1. So if you refine this 1 and 1 for the phase 1 and phase 2, now for the second atom. So but the occupancy is not good to refine, but if you cannot achieve the best fitting, then you can refine. It will tell you what is the concentration of your atomic stoichiometric crystal structure. Okay, so now refine for the second. Okay, now this one. So it will give you the approximation of between the your okay. So here you see that if you add both this parameter, it is close to 3. So now our refinement is good. Now we refine the B parameter one by one. as the barium treatment, if you get the negative, then you just refine using anisotropy, and okay. So one by one you just refine these parameters. So now you refine for the same atomic profile for the phase 2, and you see what is the parameter you get here is just close to your when you refine all the parameter, you can see it is all also close to the your stoichiometric ratio, and so it is not good to refine if you just see the this change. So you just keep it the this second phase if it is not required, because here if you refine the more the after the getting the best fit, if you again refine those parameters, so it is not well suited your XRD pattern. So now if you do the refinement, if you are satisfied with the base fitting, then you just go to the output and just create CIF file and OK, and then save it. So when you save it and run it, one CIF file is generated in your folder, and you can see the you just see first the output, what is the output, and here you see the output is your output is like 70.89% tetragonal and 29.11% is cubic. So in this way you can extract this parameter. One more thing here I would like to tell you that if you want to plot this, so here one profile, one value is generated is bt.prf, and by this you can see how good your refinement. So you can also give write the reflection file. You just go to the text and open reflection file. Okay, so here all the here you just go to the text and write reflection text. So if you write indices, position and D, so you can choose one by one for both the phases, and here you see. So this one is for the one phase, this one is for the another phase. Okay, so here it is not good idea to show you the reflection, right reflection text. You just remove and choose one by one. So in this way you can choose. Here you can extract either save data or save graphic as PGF file for your manuscript. Okay, so this is a good way to show your results. Okay, so now if you have any query regarding the this your analysis or any objections, so you can write your email or your query to my mail this okay. So now I am stopping here. Okay, thank you.